combination panel timer box is indeed considered a panelboard. The National Electrical Code, or NEC, defines a panelboard as a single panel or group of panel units designed for assembly in the form of a single panel. This includes buses and may or may not have switches and or automatic overcurrent protective devices used for the control of light, heat, or power circuits, and it is designed to be supplied by a single feeder circuit. The crucial point here is the wiring that feeds a panelboard. According to the NEC, this wiring must be installed within some type of raceway. This means using a protective channel such as conduit, cable tray, or wireway. The reason for this requirement is that the wiring feeding the panelboard is classified as a feeder. Feeders, by code definition, must be run inside raceways to provide physical protection and ensure safety. Now let's address the use of Romex, also known as non-metallic sheaths cable. Romex is typically intended for branch circuits, which are the circuits that extend from the panelboard to the various outlets and electrical devices throughout the building. Therefore, using Romex as a feeder to supply a combination panel timer box is a violation of the NEC. To reiterate, the wiring feeding the panel box must be installed inside a raceway, not with Romex. This is because Romex is designed for branch circuits, not for feeders supplying power to an entire panel board. In summary, it's essential to understand the distinction between feeders and branch circuits, and the corresponding wiring methods required by the NEC. Feeders require raceways, while Romex is suitable for branch circuits but not for feeder applications. Understanding the definitions within the National Electrical Code, or NEC, is critical to correctly applying the requirements. Firstly, a panelboard is a single panel, or a group of panel units designed for assembly in the form of a single panel. These include the buses, and may or may not have switches, and or automatic overcurrent protective devices for the control of light, heat, or power circuits. Panelboards are designed to be supplied by a single feeder circuit. Secondly, a feeder is all circuit conductors between the service equipment, the source of a separately derived system, or other power supply source and the final branch circuit overcurrent device. Thirdly, a branch circuit is the circuit conductors between the final overcurrent device protecting the circuit and the outlet. Let's clarify the differences between a feeder and a branch circuit. A feeder supplies power from the service equipment to the panel board. A branch circuit supplies power from the panel board to the point of utilization. Because of this, the NEC requires that feeders are installed within a raceway for protection. Branch circuits do not require a raceway in all situations. Conductors must be protected from physical damage. Article 300.4 of the NEC covers protecting conductors and cables from physical damage. The NEC states in 300.4 A1 that if wiring is installed parallel to framing members such as studs, rafters or joists, then the cable or raceway shall be protected where it is subject to physical damage or abrasion. Cables and raceways do not need to be a specific distance from the edge of the framing member to be considered protected. The code uses the wording subject to physical damage or abrasion. The authority having jurisdiction is responsible for determining whether the wiring is subject to physical damage or abrasion. One common method that electricians use to protect cables and raceways from physical damage is to install a metal plate. These metal plates are called nail plates. The NEC in section 300.4 D discusses protecting conductors from screws and nails. The NEC states that an cable or raceway shall be protected by a steel plate or bushing where nails or screws would penetrate. This requirement is for both surface and concealed locations. The steel plate or bushing shall have a minimum thickness of 1.6 mm, which is 1/16th of an inch. Article 310.13 covers ampacity of conductors. The ampacity of a conductor is the current, in amps, that the conductor can carry continuously under the conditions of use without exceeding its temperature rating. The ampacity of a conductor depends on several factors, including the size of the conductor, the type of insulation, the ambient temperature, and the number of conductors in a raceway or cable. The NEC provides tables that list the ampacity of conductors under various conditions. These tables are found in NEC Table 310.16 and Table 310.17. Table 310.16 is used for conductors that are insulated with a thermoset or thermoplastic insulation. Table 310.17 is used for conductors that are insulated with an extruded thermosetting and cross-linked polyethylene insulation. When determining the ampacity of conductors, it is important to consider the ambient temperature. The ambient temperature is the temperature of the air surrounding the conductors. If the ambient temperature is higher than the temperature listed in the ampacity tables, the ampacity of the conductors must be derated. Derating is the process of reducing the ampacity of a conductor to account for the effects of ambient temperature or other factors. The NEC provides tables that list the derating factors for various conditions. These tables are found in NEC Table 310.15. D1. Temperature correction factors can be found in Table 310.16 and Table 310.17. Another factor to consider when determining the ampacity of conductors is the number of conductors in a raceway or cable. When multiple current-carrying conductors are installed in a raceway, the ampacity of the conductors must be derated. This is because the heat generated by the conductors can raise the temperature of the raceway, which can reduce the ampacity of the conductors. Correction factors for the number of conductors can be found in Table 310.15. B3. The NEC provides specific requirements for the type of wiring methods that can be used for feeders. These requirements are found in Article 300 and Article 310 of the NEC. For example, NEC Section 300.11 requires that all wiring methods be securely fastened to the building structure. This is to prevent the wiring from becoming damaged or creating a safety hazard. NEC Section 310.15 requires that all conductors be protected from overcurrent. This is to prevent the conductors from overheating and causing a fire. NEC Section 310.10 H covers installation requirements for conductors in parallel. Aluminum, copper-clad aluminum, or copper conductors of size 1/0 AWG and larger, comprising each phase, polarity, neutral, or equipment grounding conductor shall be permitted to be connected in parallel. The parallel conductors must be the same length, conductor material, same size, same insulation type, and be terminated in the same manner. In summary, understanding the definitions of panelboard, feeder, and branch circuit is critical to applying the requirements of the NEC. A feeder supplies power from the service equipment to the panelboard. Because of this, the NEC requires that feeders are installed within a raceway for protection. Branch circuits run from the panelboard to the point of utilization. Romex is suitable for branch circuits, but is not permitted to be used as a feeder. Article 100 contains definitions used throughout the NEC. Branch circuits are defined as the circuit conductors between the final overcurrent protective device protecting the circuit and the outlet. A feeder is defined as all circuit conductors between the service equipment, the source of a separately derived system, or other power supply source, and the final branch circuit overcurrent device. A panelboard is defined as a single panel or group of panel units designed for assembly in the form of a single panel, including buses, and with or without switches and/or automatic overcurrent protective devices for the control of light, heat, or power circuits. Panelboards are designed to be supplied by a single feeder circuit. Article 215 of the NEC covers feeder requirements. Section 215.1 states that feeders must be protected against overcurrent. The overcurrent protection device must be located at the point where the feeder receives its supply. Section 215.2 1 covers minimum sizes for feeder conductors. Feeder conductor ampacity must not be less than required to supply the load, and must not be smaller than 12 AWG copper or 10 AWG aluminum. Section 215.5 covers identifying equipment grounding conductors. Equipment grounding conductors must be identified in accordance with 250.119. Equipment grounding conductors are permitted to be bare, covered, or insulated. Insulated or covered equipment grounding conductors shall be marked in one of the following ways. Firstly, the conductor must be green along its entire length. Secondly, the conductor must be green with one or more yellow stripes along its length. Thirdly, at the time of installation, the insulation of the conductor must be permanently re-identified to indicate its use as an equipment grounding conductor. The re-identification must encircle the conductor and be located within the enclosure. Section 215.12 covers identifying ungrounded conductors. Ungrounded conductors shall be identified by phase or system. Ungrounded conductors shall be permitted to be solid color or marked with stripes. The color orange must be used on any ungrounded conductor that is part of a dwelling unit electrical system where the system also has a grounded conductor. Section 215.13 covers the mechanical execution of work for feeder installations. Electrical equipment must be installed in a neat and workmanlike manner. Section 215.14 covers arc energy reduction. For a 1000 amp or higher feeder disconnect, a method must be used to reduce clearing time of overcurrent devices. This requirement does not apply to feeders supplying only fire pumps. The NEC provides some examples of methods to reduce clearing time of overcurrent devices. Firstly, zone-selective interlocking can be used. Secondly, differential relaying can be used. Thirdly, an energy-reducing maintenance switch can be used. Fourthly, an approved equivalent means can be used. Article 300 of the NEC covers wiring methods. Section 300.11 covers securing and supporting wiring. Wiring must be securely supported. Raceways, cable assemblies, boxes, cabinets, and fittings must be securely fastened in place. Section 300.11 B covers the support of ceiling wiring. Wiring located above a suspended ceiling must be supported independently from the ceiling. Section 300.14 covers length of free conductors at outlets, junctions, and switch points. At least 6 inches of free conductor must be left at each outlet, junction, and switch point for making connections. Section 300.15 covers boxes, conduit bodies, or fittings required where conductors are spliced. A box or conduit body must be installed at each conductor splice point, outlet, switch point, junction point, or pull point for the connection of surface raceways, metal raceways, or non-metallic raceways. Section 300.20 covers induced currents in metal enclosures or metal raceways. When conductors carrying alternating current are installed in metal enclosures or metal raceways, the conductors must be arranged so as to avoid heating the surrounding metal by induction. To accomplish this, all phase conductors and, where used, the neutral conductor and all equipment grounding conductors must be grouped together. Section 300.22 covers wiring in ducts, plenums, and other environmental airspaces. Wiring in these areas must be of a type specifically listed for that purpose. The NEC provides specific requirements for the type of wiring methods that can be used for feeders. These requirements are found in Article 300 and Article 310 of the NEC. For example, NEC Section 300.11 requires that all wiring methods be securely fastened to the building structure. This is to prevent the wiring from becoming damaged or creating a safety hazard. NEC Section 310.15 requires that all conductors be protected from overcurrent. This is to prevent the conductors from overheating and causing a fire. Understanding the differences between feeders and branch circuits is critical to applying the requirements of the NEC. A feeder supplies power from the service equipment to the panel board. Because of this, the NEC requires that feeders are installed within a raceway for protection. Branch circuits run from the panel board to the point of utilization. Romex is suitable for branch circuits but is not permitted to be used as a feeder. When installing electrical wiring, it is important to follow the requirements of the NEC. This will help to ensure that the wiring is safe and will not cause a fire. It's crucial to distinguish between feeders and branch circuits. Feeders, which supply power from the service equipment to the panel board, are required by the NEC to be installed within a raceway for protection. Branch circuits, on the other hand, run from the panel board to the point of utilization. While Romex is suitable for branch circuits, it's not permitted for use as a feeder. When dealing with electrical installations, always adhere to the NEC guidelines to ensure safety and prevent fire hazards. NEC 310.15 covers ampacity. A conductor's ampacity is defined as the current in amps that it can carry continuously without exceeding its temperature rating. The ampacity is affected by conductor size, insulation type, ambient temperature, and the number of conductors in a raceway. Tables 310.16 and 310.17 in the NEC provide ampacity ratings for conductors under different conditions. Table 310.16 covers conductors with thermoset or thermoplastic insulation, while Table 310.17 is for conductors with extruded thermosetting and cross-linked polyethylene insulation. Ambient temperature affects conductor ampacity. Higher ambient temperatures require dilating the conductor's ampacity. Dilating factors are available in NEC Table 310.15. B1. While temperature correction factors are located in tables 310.16 and 310.17. The number of conductors in a raceway also affects ampacity. Multiple current carrying conductors in a raceway require dilating due to heat buildup, which reduces ampacity. Correction factors for the number of conductors are found in table 310.15. B3. Additionally, Article 300.4 of the NEC addresses protecting conductors and cables from physical damage. It states that cables or raceways installed parallel to framing members like studs, rafters, or joists must be protected if they are subject to physical damage or abrasion. The authority having jurisdiction determines if the wiring is at risk of physical damage or abrasion. One common protection method is using metal nail plates. Section 300.4 D of the NEC covers protecting conductors from screws and nails, stating that NM cable or raceways must be protected by a steel plate or bushing where nails or screws could penetrate, both in surface and concealed locations. The steel plate or bushing must be at least 1.6 mm or 1/16 of an inch thick.